Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. I would like to welcome all of you to our third research webinar. Alhamdulillah, we managed to arrange for this one after a few postponement. For this time, two of our students will share their findings. The main aim of the webinar is to share our findings with the public. And number two is to give experience or exposure to the student to present in the public, even though at the online mode, and also to build connection. Hopefully, by this presentation, there will be a collaborator from other institutions or from the companies to work with us in this area. Okay, before we start, I would like to give a brief briefing or brief background about the presenter today. It's easy because they are from the same institution. They are registered about the same time. Kamarul and Ame come from same institution, which is the ETEC Kulim. They are lecturer there for quite some time. They are both also pursuing their PhD study under Ministry of Higher Education. They got a sponsorship for this study. So later they will have a contract with the government. Okay, without further delay, I would like to call the first presenter, Kamarul Al-Hafiz, to share his findings. Okay, the floor is yours, Kamarul. You can start when you are ready.
Okay, thank you. Assalamualaikum and very good afternoon to all members and our SB, Associate Professor Dr. Ahmad Baharudin. Is it my voice is clear?
Yeah, very clear.
All right, thank you. So, not to further delay, I would like to present. I would like to share my topics, which is related with my study today. All right. Okay. Okay, everyone can see it? Everyone can see my slide?
Yes, can see.
All right, thank you. Okay, I proceed. Okay, my topic to share, I would like to share today is about the performance of tele-welded blanks during Singapore incrementing forming. Okay, my study is related with one of the incremental sheet forming, which is SPIF, combined with tele-welded blank specimen. Okay. Okay. Application of the tele-welded blank.
Yeah. Sorry to interrupt. Can you
slide?
Yeah.
Okay. Sorry. All right. Sorry. Slide. All right. Okay. The tele-welded blank are defined as a two or more separated pieces of a flat material, the similar thickness and or mechanical properties joined together before forming to provide a customized and superior qualities. This is the advantages of the tele-welded blank. The tele-welded blank also widely used in automotive industry, including the side frame store, pillar rails, and whatever application. Tele-welded blank can help the design solution in order to reduce the material cost and weight, improve quality and performance while optimizing your production processes. So this is the example the application of the teleweather blank in industrial. So we have some combination of some different materials or different thickness by reduction of the weight of white body, such as a window frame, B pillar outer and inner, door inner, with header, chassis from front frame. Okay, I would like to share about the process of the incrementing sheet forming. Incrementing sheet forming is a process which a sheet is shaped into the final part shape by progressively applying small increment of deformation using a round tip or hemispherical head tool. Typically, the diameter of the forming tool is the range between 5 to 20 mm diameter. The tool is mounted on a CNC machine or robot arm, and its motion is controlled by a computer program that generates the tool path. Okay, the first picture is the first picture show the working principle of the SPIF. They consist of the clamping, blank holder, backing plate, but this process is dieless. Then have a rotational forming tools, forming speed. Then also have a design wall angle. Okay, then I specified that. The second picture is a setup on a CNC machine, and the last picture is show the SPF toolpath that designed or created using CAM software. Okay, before I go further, I want to just share the some different process in ISF. In ISF, majorly they have three types in incremental sheet forming, which is the first one, single point incremental forming. Single point incremental forming is consists only one rotating tools and dieless process. So this is a very simple setup process, and also the process is dieless without die. The setup process also easy. Okay, the setup cost also not including the die. By rotation the tool, then form the shape into a design, into a required design. The second one is a 2-point incremental forming, TPIF. Different with the SPIF, the TPIF have a die, but some researchers divide into a two type of a TPIF, which is the first one is a partial die, the second one is a full die. So different with SPIF is a dieless without die, but TPIF they have a die which is partial or full die. And the third one is a double-sided incremental forming. Different with SPIF and TPIF, the SIF have two rotating tools at the top and the bottom of the fixtures. So both forming tool will rotating and move together to form the desired shape. So the DSF required high complex programming and also high setting up cost. Depend on compared then SPIF and also TPIF. All right. So another thing is the process of incremental forming is very complex, and like a 3D printer concept is produce a complex shape, then custom shape means this process of incremental shape forming are not produced very mass production in high quantity of part, not same like a stamping process that can produce 100 or 1,000 in a minute or in minutes or hours. Okay, in SPIF, so my study is focused on SPIF. Okay, so in SPIF, they have some important process parameter such as rotational speed, feed rate, step size, forming angle, or some researcher put as a wall angle, lubricant, diameter tools, and sheet thickness. But in my research study, I just focus on the four variety of parameter, which is rotational speed, feed rate, step size, and forming angle. The another parameter such as thickness, another parameter I try to fix such as sheet thickness, diameter of tools, and the lubricant. Oops. Okay. Gaps in the literature. Okay. From the available literature, it can be summarized that there is a limited understanding of the input of also process parameters affecting SPIF performance. Number two, there's a limited work has reported on the dissimilar telluride AA6061 and AA5052 alloy by using SPIF. And the last one is from the available literature, there is no or limited research work has been found on the springback on telluride blank using SPIF process. Actually, this is quite interesting in my research study because the first thing is quite novelty when I already make some research, make a study on my previous semester. There's a very limited regarding combination of SPF and telluride blank. Normally, they have a several researcher that combine the process of FCPS with a telluride blank as a specimen, but most of them and almost the research are focused on the formability. Okay, formability. But until now, I'm still not found another research that focus on the springback. Springback that occurred when SPF process form on the telluride blank specimen. So this is quite I don't see there is no research at all, but in still now in an English publication paper in English language means I still not find the article that related with springback on telluride blank using SPF process. Maybe I'm not sure. Maybe in the others language on a paper such as a Russian, Chinese, Arabic. I'm not sure if they already study on that. Okay, so here I'm stated the overview of the common issues in SPAF during on a sheet metal forming, which is they have three kind of defect. Which is the first one is unwanted sheet bending. Unwanted sheet bending is near with a clamping and unclamping workpiece on that side. The second one is a springback. Springback more to focus on the wall angle area. And the last one is a pillow effect. Pillow effect is related with a depth of the forming. Okay, so my study is focused on the springback. Okay, this is the methodology of my study. First of all, to proceed this kind of study, I have to prepare the telluride blank sample, the combination of the dissimilar materials 6061 and 5052. Then this process of telluride blank, we go through friction stir welding. Sorry, I'm not focused on the process of friction stir welding because the others member on previous sharing webinar session, Mr. Zuhairi already shared about that process. So after we prepare the samples, the next one is prepare the design of the experiment using a Taguchi method. Then here I pick, like I said just now, pick a 4 type of parameter, which is rotational speed, forming speed, step side, wall angle, with a 3 level. Then we try to run the SPF process. If fail, we try to make some alteration or amendment at the process parameter. And if the part is successful form, then I measure the springback angles. So actually, on the parameter, I already make some research and also refer from the previous researcher because like I said just now, previous researcher focus on the formability, but they still running the process of SPIS. So their parameters I take as a reference, but some parameter I'm not sure is it the parameter is a valid or maybe have a typing error on that paper because I'm already follow the several parameter but it's fail when I test in my specimen. So on that time I take several time to change the parameter. Then after specimen was failed, I need to produce the specimen again using friction stir welding, and until we will get the proper parameter. Okay, so we will measure the spring back angles for the form part. So here I put the illustration of the conical design, which is we have two different type of material. The left one, the alpha angle, refer for angle for material 6061. The beta angle on the right one refer to 5052 materials. So the measurement I will conduct using a CMM Mitutoyo at USM. So here we measure 10 points on each side. Then I will find the average angle of the form shape. Okay. Then analyze the result by using the SN ratio result, and also the ANOVA. ANOVA is used to I used to share the contribution percentage of each parameter, the most contribution percentage on parameter that influence the spring back. Then after that, we try to find the optimized parameter, then make a confirmation test, then remeasure the spring back angles. Okay. Okay, here have a nice sample after design on the Taguchi method. They produce a L9, mean nice sample with a combination the four different parameter at 3 levels. Then we have a nice samples. This is a nice sample that I already formed. This is the illustration of the point on the wall angle of the form pipe, measured by Mitutoyo CMM, and I interpret the result on Excel to find the value. Okay, the result. So this is the how to measure the spring back, which is after we find the average angle of spring back, then a standard calculation of the spring back is actual spring back minus design spring back. Then we find the actual spring back. Okay, so based on the nice sample 8 produce a very less spring back on both sides, which is on materials on 6061 materials produce slightly different on a actual or design angle, which is 2.2 at 5 degree. For another side, 5052 material produce as 2.6622 degrees, slightly different with 65 degrees that design angle or what angle. Okay, so on a SN ratio based on Taguchi analysis, we can see that spring back on AA6061, they have a optimum value for rotational speed is 1750, forming speed is 600, step size is 0.2 mm, and wall angle is 65 degree. Same goes to a spring back on AA5052 side. Also give a same output on optimum parameter. Both sides have a less spring back compared than the other sample. Okay, so both sides propose the next for running for the optimum parameter is 1750 RPM, 900 mm per minute for feed rate, 0.2 mm for step size, and 65 degree of wall angle. Okay, so both side of the materials produce a very less spring back based on the parameters. Okay, as a summary, based on a Taguchi method, the SN ratio results show the wall angle is a significant parameter that influence the spring back compared than other parameter at both major sites. While rotational speed on the last rank show it doesn't have a significant effect on the spring back angle. So ANOVA will the ranking of the SN ratio will show the ranking of the significant parameter. So on spring back at 6061 show the watt angle is very significant. The second one is a forming speed. Third one is step size, and the last one is a rotational speed. On the 5052 side, they have a same significant parameter, which is the watt angle, and also the very less significant, which is rotational speed, but quite different the result between forming speed and step size. The optimal value for rotational speed, forming size, step size, or watt angle are determined using a rank of significant parameter, like I explained just now. Okay, then according to the ANOVA result, the watt angle has a greater percentage effect on the spring back angle of form Tailor de Blanc, which is 94.73% for a spring back A or mean spring back 6061, and 93.18% for a 5052 site. Okay, then that contribution is high because using ANOVA, we usually have a significant for 95%. So less than 95% is a very high contribution. The percentage error on the form part during the confirmation test is less than 1%. Means the last point is comparison between the confirmation test sample with number 8 samples. Okay, sebab the percentage error from confirmation is less than 1 mm compared to sample number 8, which is for 6061 sample, just a different 0.522%, and for 5052 site only have a 0.701%. Mean both of the major site have a slightly different, and less than that different is a less than 1%. 1%. Okay, this is challenging during this process when I combine together process SPIF and Tailor de Blanc. Okay, actually this process, the challenging is started when to provide the sample itself, because when the material thickness is very thin, it's very difficult to weld. It's very difficult to weld because due to warpage issue and also the defect issues about the during the process, because the friction stir welding also provide the high residual stress, also the heat distribution. So when the specimen is thin or less than 1 or less than 1 mm or less, means the possibility to fail and warpage is very high. Whereas if the plate is, our sheet is thin, 1 mm or less, it's easy to form. It's easy to form. But if the specimen is quite thick, I mean maybe 2 mm and above, it's very easy to weld. Then there is no warpage at all if we use 2 mm thickness at 2 mm material thickness. But it very difficult to form. So like I show in this illustration that I said, when the material thickness is become high, it's easy to weld but difficult to form. But when the thickness is less, it's easy to form but difficult to weld. So this is the challenging when I need to prepare the sample. Okay, so because this is so many times I how to reproduce the specimen, because due to fail, due to difficult to produce, then I decide to pick a 1.5 mm for different materials. So far the forming and also the welding going smoothly. Okay. The second one is issue. The second issue is about the setup time, because the setup times using SPIF is quite challenging, because we have to setting properly the tools, that need to point 00 on the workpiece. Because when we open the feature, then we need to set up again. But for the first time only, unless the machine is not available, means they have another the undergraduate student that need to use. So we don't have any choice, need to open up the setup, then need to set up again. So it will take a time. The third one is a process time of the SPIF itself, because the previous SPIF normally they are using even CNC machine or robotic arm. They use a very thin sheet of metal. Sometimes they use 1 mm or less of the material thickness, so it's easy to form. Then there's no issue for a fast or quick process. But when we use a tallow at the blank, this is a 1.5 mm and welded, means there is not easy to form with a high speed, because like I said just now, I already done several times combination the parameters. So how many fails, then need to adjust the parameter again and again, means I have to slow down the step size, slow down the feed rate, so the processing time will expand. So previously, for the first or second time I do, the processing time is about 5 hours and plus for one specimen. So it's quite difficult. It's quite because this is incremental forming. It's not just I said just now. It's not a stamping process, but this is the high accuracy of process, means they have to go through a forming with a slowly process. Okay, here's the parameter that I used before. Okay, using 100,000 RPM at 100 and 0.2 if I'm not mistaken. But there is stuff changing because the parameter I already changed, but the processing time is around 1 to 2 hours. Okay, in the future works. Okay, in the future works, actually the future work also related with my objective, my objective of study. The first one, I would like to identify the relationship between the thickness distribution and the spring back. The spring back on the welded region, means here I show the BM. BM stand for base metal, uniform region, base metal form region, and base metal and telluride blank form region. So um, I I would like to study the thickness distribution, also affect the thickness distribution and the spring back, the relationship between the thickness distribution and the spring back. Then any effect on the base metal, also what different between base metal structure and also telluride blank structure. Is it any significant effect on that area? Because I will go to the thickness distribution, also the microstructure on that area. This is my next planning. The second one, um, I would like to investigate the improvement of the spring back angle reduction by composition process, which means I try to introduce some new process, which is a reverse single incremental forming. Just reverse single incremental forming means the common SPIF is just one direction only, from downward position only. But when I study several process, SPIF has a lack of geometry accuracy compared than TPIF and DSF. So DSF and TPIF, they both have some force at the bottom of the fixtures. Mean SPIF is a diless process, mean just only one direction of the force to form the pipe. But for a TPIF, they have a partial die and full die, and DSF, they have a both rotating tool at the top and the bottom, means they have a something force at the bottom of the fixture that counter back or reverse the first force simultaneously, or maybe not simultaneously. But this process, I try to introduce the return force, means after the first process, that common process of the SPIF, just only one downward process, and after the process was done, the tool will return at the same path, but I try to make some adjustment with offset the tools, then return back. Means they have another force to go upward as a replacing a die or rotating tools. It's not the same, but we try to keep the same process of SPIF, means same dieless process, but we try to make some adjustment on the tool pass. So this is, I think this is quite interesting because this is a new process. Quite, I have a something new in my research, and also mm, I think this, I'm not sure about the result because I still on adjustment the Mastercam software to make it reverse. But I think this is some interesting to explore lah, because this is the new but different implementation. Okay, all right. Okay, that's all. So thank you for your attention.
Okay, thank you, Hafiz, for the presentation.
Yeah.
I think we further we move to the second presenter, Ahmed Ishraqi. You can start if you are ready. Ahmed?
Yeah. Okay, I am ready now. Can see my slide or not?
Okay, Ken.
Yeah.
Okay. Yes, Assalamualaikum and good evening. So I am Ahmed Ishraqi bin Husin, a PhD student from Metal Forming Research Lab, USM. So today I would like to share my finding about my current study, which is about the effects of joint configurations of teleweather blank on crashworthiness behavior. Okay, before I begin sharing my topic about the type of joints, let me introduce a little bit about the teleweather blank in the crashworthiness. Okay, crashworthiness is the ability of the vehicle to protect its occupant during an impact or accident. So the ultimate goal of crashworthiness is to protect occupant in a wide range of crash scenarios and reduce the risk of injury or death in the event of an accident. Side impact is also known as crash test. It's one of the awful hazardous crashes which causing deaths and injuries around the world. The side impact on a car structure involve a roof rail, B-pillar, and seal. One of the methods to reduce the risk during collision from the side is by strengthening the B-pillar structure, such as friction stir welding for joining purpose or by using advanced material. So in a study by Kelly, they found that scapular fracture or shoulder injury influenced by B-pillar in more cases of side collisions. Investigating the joint configuration of friction stir welding for teleweather blanks is considered as an alternative approach to enhance and strengthen of automotive structures, thereby improving their crashworthiness. This is the applications of the teleweather blank in automotive parts. So as we know, one of the methods to produce teleweather blank is through friction stir welding. In the slides, show the example of application of teleweather blank in automotive frame parts. So approximately 50 teleweather blank application can be seen in the diagrams, with this study focusing primarily on the B-pillar section of the vehicle. For information, the B-pillar, also known as the center pillar, is a vertical structure component located between the front and the rear door of the vehicles. It provides support to the vehicle roof, helps to maintain the structural integrity of the passenger compartment, and serve as an attachment point for the seat belt and other safety system. In some vehicles, the B pillar may also houses airbags or other safety features. So for the purpose of the presentation, I have structured my presentation into two objectives. The first objective is to compare the different types of joint configurations in friction stir welding. And second is to optimize friction stir welding machine parameter for double butt lap joint by using Taguchi method. So the cross-section diagram on the left show this show section utilized for conducting. The left diagram section is used showing the sample used to conduct multiple tests such as tensile, hardness, and microstructure analysis. So on the right-hand side, the diagram show the bending test used to obtain stream back value under different friction stir welding parameters. So basically, the type of joint configuration in friction stir welding same as the arc welding. So for example, the typical types of joint configurations is square butt joint, H butt joint, T butt joint, lap joint, multiple laps joint, T lap joint, and fillet joints. On the right side is the joint configuration for the modified square butt joint, which has been improved to a new shape, which is called a scuff joint and double butt lap joint. So this is the methodology for my experiments. So in order to make a comparison between the three types of joints, the same parameter have been used for tool design, material size, machine types, and machine parameter. For the friction stir welding tool, I'm using D2 tool steel, and the the shape of the pin is a straight cylindrical, and the pin length is 1 mm, pin diameter 5 mm, shoulder length 10 mm, shoulder diameter 10 mm. And for the variable parameter, different rolling angle are used for each type of joint. There are 4 types of joint angle combination that are carried out, such as 0, 0 degree, 90, 90 degree, 90, 0 degree, and 0, 90 degree. So the material used for this friction stir welding comparisons is aluminium 6061. The thickness for advancing side is 2 mm and the rotating side is 1.5 mm. The dimensions is 200 times 90 mm. So the three type of joint configuration for the comparison is square butt, scuff, and double butt lap joint. So this is the flow of the experiments. Start with the friction stir welding process, then the sample preparation, and the last one is the analysis. So for the friction stir welding, I'm using a conventional universal milling machine. And the fixed parameter for the friction stir welding process is spindle speed, 865 RPM, welding speed, 90 mm per minute, and tool tip angle is 3 degree. So for the sample preparation for the tensile, hardness, and microstructure, I'm using EDM wire cut to cut the specimen profile. And for mounting or for holding the specimen, I'm using specimen mounting press. This is for microstructure and the hardness test. And next is the analysis. The analysis is for comparison using the tensile test, UTM machine, hardness test. I'm using vehicle hardness tester, and microstructure. I'm using optical microscope and SEM machine. So this is the results, comparison on ultimate tensile strength results. So the UTS value for each rolling angle is different. From the chart, it can be seen that a combination of different rolling angle value give higher value compared to the joint that have the same rolling angle values. So we can see that DBL or double butt lap joint is better than square butt joint configuration by 3 to 11%, and much better than scuff joint configuration by 2 to 6%. And the best rolling angle is the combination of 90 and 0 rolling angle for all type of joints. So next is the comparison of the hardness HV results. Okay, next, to form the hardness profile, the hardness value is measured every 2 mm from end to end, including all the stir zone and material base area. So as we can see, by changing the geometry of the joint from an SV, square butt, to scuff joint or DBL, or double butt leg joint, we can increase hardness value on the stir zones. However, the hardness value between the scuff and double butt joint will not significantly different. Okay, this is the comparison of microstructure analysis. To see the difference in microstructure for each joint, scanning electron microscopy SEM will be used. So before it can be seen under the SEM, the sample must first be polished until it reaches the mirror surface finish, and then etching process will be done by dipping the sample into color region for 15 to 30 seconds. So as we can see, the same result show that the grain size of each joint is different at the stir zone. So we can see the size for base material is 70 to 100 micrometer. So the stir zone, for the stir zone, the square butt, the microstructure size is 30 to 40 micrometer. And for the scuff, the average size is 15 micrometer to 20 micrometer. And the last one is the double butt leg joint microstructure. The size is 10 micrometer to 15 micrometer. So the best or the smallest size of the grain size is the double butt leg joint. You can see the different, the big gap between the other joints. So this is the comparison on S-line shape. The microstructure of the joint can also be used to define its strength by comparing it to the S-line defects. Figure A, B, and C show that the 3 type of joint cause 3 type of S-line defects. S shape for square butt, curve shape for scuff, and V shape for the double butt leg joint. The S shape profile in figure A has the longest line, followed by the C shape in figure B, and the V shape in the figure C. So the tensile test revealed that the square butt joint has the lowest UTS value, and the double butt joint has the highest UTS value. So this is signifies that the shape and the length of the S-line profile influence the strength of the friction stir welding joint. So the S-line shape is caused by the geometry configurations of the welding area, where each joint has a different surface area. So which of the joint is better? Square butt, scuff, or double butt? So based on the tensile result, it was found that the UTS for the double butt lap joint is better than square butt joint configuration by 3 to 11% and much better than scuff joint configuration by 2 to 6%. So by changing the geometry of the joint from square butt to scuff joint or double butt lap joint, it has been observed that the hardness value of the stir zone increased. However, the hardness value between scuff and double butt lap joint were not significantly different. By increasing the contact area of the fairing surface, the value of material that needs to be pumped into the wet root is enhanced, resulting in optimal wet formation and consolidation in the wet zone. The double butt lap joint design has proven to be optimal design strategy for increasing the fairing surface and, as a result, improving the mechanical properties of the joint. Apart from the rolling angle factor, the type of joint influence the S-line profile where the profile tree joint differ. Okay, this is next we look my second objective, which is to find the most optimal parameter to get the best spring back value. So to determine the number of experiments the appropriate combination of parameter, the Taguchi method was used and all result analysis were made using Minitab software. So Taguchi LNAIR orthogonal array design lists 9 combinations of different parameters. So this 9 combination consists 3 levels of spinner speed, 3 levels of feed rate, and 3 levels of tilt angle. So this is the friction stir welding output, which is the bending process. 2 spring back values being measured for different welding direction, which are perpendicular and parallel. So the spring back value is calculated by subtracting the loading angles theta 1 and unloading angle theta 2 as shown in the figure. So this is the results from the experiment designed by the Taguchi method. So this is the graph for the main effect plot for the SN ratio. As you can see, it was discovered that the best parameter for both swing back outputs are also different as referring to the figure and A and B. So from the graph, it was discovered that the best parameter for the spring back for parallels to weld lines is 1140 for spinner speed, level 3, 90 mm per minute feed rate for level 2, and 2 degree tilt angle, level 2. And for best parameter for perpendicular to weld lines, the feed rate is 865 level 2, spindle speed 127 level 3, and tilt angle 2 degree for level 2. So different parameter for different weld line. So after the test and getting the result, I'm doing the confirmation test. The confirmation test was used to compare the experiment result to predict the outcome. So the table shows the margin of error value between predicted and experimental result for the spring back values, whereas the difference is only 6.63% for parallel and 3.35% for perpendicular to weld lines. This means all the experiment data and the result are trusted and reliable. So the summary of my 2 objectives is, the first one is to, if DBL is better than square butt joint configuration by 3 to 11% and much better than scuff joint configuration by 2 to 6% in terms of tensile results. Double butt joint produce a V-line profile of S-line, demonstrate that the best quality of three types of joint in terms of tensile, hardness, and microstructure result, followed by scuff and square butt joints. So based on the investigations, it was determined that the optimal parameter setting for spring back parallel to the wet lines were 1140 RPM spinning speed, 90 mm per minute tick rates, and 2-degree tick angles. For spring back perpendicular, the wet lines, the optimal parameter were 865 RPM spinning speeds, 127 mm per minute rates, and 2-degree tilt angles, level 2. So as the conclusion, the double butt leg joint is a good alternative for reinforced friction stir welding joints, while simultaneously enhancing the application of tailor-welded blanks in vehicle frame, especially B-pillar, to further improve crash worthiness. Okay. Okay, I think that's all for me now. Any question regarding my topic, please ask me. Thank you.
Okay, Alhamdulillah. Thank you, Kamarul and Amir for their sharing, for their presentation. Okay, I would like to open to the floor for any question regarding their study or others. Okay, Fadil.
Assalamualaikum. Assalamualaikum warahmatullah. Sabar tak jumpa ya. Okay, thank you. I would like to ask one question for Kamarul and another one for Amir. For Kamarul, I wish to know whether when you did the SPIF, what's the effect, or is there any failure where the tool goes over the well, or did you consider those things, or is it included in your evaluation?
Okay, thank you, Mr. Fazil, for the question. Actually, on the nice samples that I have run using the depth parameters, that means there is no crack, especially on the welded line. So another thing is, if my study is not on the formability, my study is to measure the spring back, means all nice samples provide a good shape without any crack. Okay, since if they have any cracks, means we have to check not only for the SPI parameter, but maybe we have to investigate the parameter on that friction stir welding also, because maybe on that process they can affect the joining that can crack during SPI process. But on my study, all nice sample is done very smoothly and successfully without any crack. That's all, Mr. Fazil. Is it answer your question?
Yeah, because
thank you.
My study is on the cracking, so I was wondering whether when you have, exerting force on the well, whether anything is, any defect on the actual line. So I believe that the frictions, the welded components are very stable, lah.
Yep, absolutely.
Okay, thank you.
Thank
and soalan to Amir, just I was wondering that double butt too, meaning that the well is overlapping lah. Maknanya you did one on the top and then the other one at the bottom, so the well to actually overlap lah.
Actually, double butt, we call it DBL, double butt leg joint. It's a same joining method we use as the square butt joint. No,
Okay.
we call it double because it has two butt, right? It's a two butt, And when we join the two joint of the metal, and is what we call it produce overlap one of the butts.
Yeah. So
Yeah.
so meaning one you did one on the top, and then it's turned over, and then you did another one at the bottom lah.
No, just
Oh,
one only.
straight.
Yeah, straight.
Okay,
Same as square butt.
Okay.
Only the
It's
joining.
actually combination of butt and lap.
Okay. So
But you cut so hard because you want to level it.
Okay. So okay. So maknanya this there is a single pass welding lah.
Yeah,
Yeah.
single pass.
Okay. I was thinking it's a double. You do one and then you push over and another one. Okay.
Actually, this type of joint usually used by the carpenter.
Okay. Alright.
Okay, thank you, Fadil, for the questions. Okay, any other audience would like to ask question? Okay, from the chat box, Zulkari asked Kamarul, what is the limitation of your work?
Limitation during my research, actually I already shared in a slide, but it has another limitation, such as the access to using the CNC machine itself, because it doesn't matter at Tech Kulim or USM, they have their own authorized person that in charge to operate that machines. Mean the process sometimes delay 2 to 3 weeks, maybe 1 month, due to the schedule that undergraduate students use. Then we have to waiting until the schedule is free. This one thing. The second one is my limitation is about the info. Since like I said just now, the combination between the info or the article that related with SPF on Teluk at the Blank itself, very limited. They have a several research out there, but like I said, it's a very limited. They have a just standalone on SPF on a single not a Teluk at the Blank sheet, but a homogeneous sheet, or but on combination both SPF and Teluk at the Blank is quite difficult to find. This is my limitation on this limitation that I face in my study. That's all.
I think Zul Khairi's question is about your scope, not your what is your difficulty doing the work, the scope of your study.
Oh, okay. If scope of my study is okay, I'm just pick on my preparation of sample lah, because especially on the failure sample, because even Ami and Zul also know my biggest problem when I prepared the fitness sample, even the problem on the tool itself, and also the combination, because previously my design of experiment is combination between two dissimilar material and two dissimilar thickness, but the issues during the process of fitness term make it I have to change my design of experiment. Means I need to fix the standard thickness but different materials. That's it. Because due to the process, the warpage of the plate, the workpiece after welding, and also the failure when the welding tools is go to the plate, means the plate was failed. So that's it.
Okay, for Ame, also from Zulkhairi, it is possible to use the same optimize and the FSW parameters in your study to join other aluminum grade or thickness? Please unmute first, Ame.
Okay, sorry. Okay, sorry. Thank you, Mr. Zul, for the question. Okay, I think to use the same optimized parameter is not suitable to be applied for other material or other thicknesses, because I think the first is because the material itself have different mechanical properties. So when we doing the friction stir welding, it from the friction itself, it generate different heats to melt the material, because different material have different melting point. So we need to study the best parameter for the material to mix or to melt. So for me, it's not suitable to use that parameter for other material. And second, about the thicknesses, I think the different thickness need different type of tool design. So because the tool design is the most important thing, because every thickness use a different pin length or the different shoulder diameter. So different thickness need different tools, different design tools, different size. So I think it's also not possible or also not suitable to use the same parameter. Okay, thank you. Does that answer your question?
Okay, any other questions?
I want to ask Ame. Okay, Ame, I just want to know, is it what is I want to ask what is related between the friction stir welding, the process of the friction stir welding, with your study on crashworthiness? That's it.
Okay. Okay, thank you, Mr. Kamarul. So to understand how friction stir welding related to the crashworthiness, first you need to understand what is the crashworthiness itself. So the crashworthiness is the ability of the vehicle to protect its passenger from the injury. So to protect the passenger from injury, you need a strong structure, right? And to make the structure, you need a good telewelded blank. So to make good telewelded blank, you need a good joint of friction stir welding. So it's interrelated lah between friction stir welding, telewelded blank, structure, and crashworthiness. So if you can see in detail, friction stir welding is the initial process from all the steps to produce a car structure. So I think it is very important to make a strong joint in the first place to make sure we have a good structure or frame, and at the same time we can reduce the risk of injury and we can increase the crashworthiness factor. So I think this is how friction stir welding related to the crashworthiness. Okay, thank you.
You're welcome.
Okay, thank you. Any other questions from my new students?
Assalamualaikum. Is it clear?
Okay, yeah, Syafi.
Azam.
Azam or
Azam,
what?
Azam dulu. Tuan Guru Azam dulu.
Okay, sorry.
Azam.
Okay.
Okay.
How do you do? All. Okay. I just have one question. Whether Ame or Kamaru can answer this one. This is regarding the what call that, the actual experiment value and also the prediction. At the last of the presentation, that Ame mentioned that there is some error between prediction and the experimental result. So, what kind of a model or formula that you use to predict the value for the prediction? Is it using software or using a formula? That is my question.
Oh, okay. For my case, the prediction is from the Meditech software. I don't use the formula, so get automatically from the Meditech formula for me.
I see.
Okay, I just want to add what Ame, what answered by Ame. Same with me. I also use Minitab to make some prediction about my experiment result. So since my result was since I have 9 samples, then the 8 sample is very how to say produce a less spring back. So the prediction is same with the 8 sample parameters. So if the SN ratio provide a different or combination of the parameter on orthogonal array from Taguchi is different, then the prediction also will provide a different result lah. So we will follow the prediction by Minitab software, then as a result for prediction lah. So same like Amir said lah.
Okay. Because if we use another model, for example, we also can calculate the prediction for the value for the prediction. Because during my study previously, I'm not using a Minitab as a method to calculate the prediction value. I'm using a model that introduced by, if not mistaken, T. Kumar. That also can be calculated to the prediction value by using the only for the significant parameter only in the calculation. It's just I just want to share with both of you lah. Okay, thank you. That's all for me.
Thank you, Dr. Azam.
Thank you, Dr. Azam.
Thank you, Azam. Dr. Azam. And next, Dr. Syafiee, Pak.
Doktor. Tak, saya bukan doktor. Saya nak tanya
kita
bahasa
Wi-Fi.
Melayu je lah. Bahasa Melayu je lah. Okey. Saya nak tanya berkenaan dengan Taguchi method tu. Sebab kan buat L9 orthogonal array tu. Jadi kita macam ada limit number of run lah. Maksudnya ada 9 run. Jadi bila 9 run ni, bila kita buat linear prediction, sama ada menggunakan regression model ataupun ANOVA, kan. Jadi dia punya R-square error tu. R-square error tu berapa? Dia bawah 80% ke, 90% ke atas ke? Sebab makin banyak point, lagi better kita predict dia punya graf tu yang linear. Sebab Taguchi ni dia macam linear prediction. Dia tak macam yang lain macam AI ataupun machine learning punya prediction. Dia lebih kepada linear lah, kan? Jadi dia sangat penting untuk kita R-square error tu dia tinggi. Maksudnya kita error, orang kata best plot tu lah. Best plot tu error dia kecil. Boleh saya tahu tak berapa error yang untuk R-square value tu?
Yeah, there is always conflict between finite element expert and also statistical expert.
Dan saya perhati juga macam Amir dan Amarul kan menggunakan signal to noise ratio. Jadi kalau untuk Taguchi signal to noise ratio maksud ada noise sebab kan kita sebelum tu eksperimen tu untuk contoh kan kita ada 9 run. Untuk run yang pertama itu ada repeat tak? Macam 3 kali repeat ke? Run yang kedua kita menggunakan control factor yang macam ni, kemudian dapat result iaitu respon kita contoh macam tensile strength ke kan ataupun ultimate tensile strength tu. Jadi berapa bacaan untuk run yang pertama berapa kali ambil bacaan untuk ultimate tensile test untuk spesimen yang pertama tu? Ataupun tak repeat, cuma run 9, maksudnya ada 9 spesimen ke?
Okey, untuk saya jawab yang soalan yang terakhir lah.
Betul.
Sebab yang berapa R-square, berapa tu saya nak kena check balik Minitab, saya nak kena buka balik. Berapa saya punya error tu, saya tak ingat lah. Untuk yang 9 punya bacaan tu, memang eksperimen untuk saya buat friction stir welding tu, sampel memang saya buat 9. Tapi untuk tensile selalunya saya akan buat 3. Saya akan buat 3. Untuk setiap
Amir, English please. There is also international student.
Oh, okay. Sorry. Oh, kena speaking
Yeah.
Okay, from the number of experiment, I do it nine experiment only. But for the result for the tensile test, for the one experiment, I take result. I do it for 3 times. Then I get the average value. So for 9 experiment, I have 27 tensile specimen lah.
I see. So so that's why you use what we call signal to noise ratio, because sometimes people they don't have enough specimen, so they just repeat one experiment for 9 run, so there is no noise. So if you repeat 3 times, so we have different value, so that we have a noise, because each tensile value, we have different tensile value, so there is a noise there. That's why we have a yeah, then that's good, because some paper from India, they really tekankan R square value tu. Make sure katanya, tak silap saya 86% ke atas macam tu, dia lebih bagus lah dia punya prediction tu nanti. Dan macam mana select dia punya apa nama tu? Level. Contoh macam kita let's say you have a rotational, you have a different RPM. So how do you choose that range? For Amir.
Okay. For me, I using 3 level.
Yeah, 3 level.
So 3 level, 3 stages lah. So 3 level for spinning speed, 3 level for fury, and 3 level for tail angle. But the baseline is let's say what is the baseline for the references for I'm starting to select the parameter. So this one is actually from the try and error once, and another one with the I compare it with the previous recession that using the same thickness, the same material. Then by combining the two references that I get before, then I made my own parameter, then make it separate it to the 3 stages.
I see. Okay, so based on previous research and try and error.
Yeah.
Yeah. Okay, I see. Wow. Okay. So for regression, meaning that you have a continuous and categorical, what we call that, dependent variable. So for response, you have, let's say, dependent variable, you have tensile strength and all those stuff, isn't it?
Yeah.
So for the independent variable, you have a rotational speed, you have a different independent variable. So how do you analyze in Minitab? Because different regression method will result different prediction. Let's say you have contohnya, misal kata Amir ada apa nama tu? Ada RPM, kan? Different RPM, and then that one is continuous variable, and then you have a different joint, let's say 3 jenis joint yang berbeza. So joint tu dia bukan continuous, tapi dia kategori. Jadi bila kita nak analyze result daripada Minitab tu nanti, daripada Taguchi data tu nanti, sama ada kita boleh guna Taguchi method, kita boleh menggunakan regression model, kita boleh menggunakan ANOVA. Ketiga-tiga ni sebenarnya regression, tapi nama yang berbeza-beza. Kalau untuk Amir, sebenarnya dia lebih baik kalau menggunakan ANOVA. Dekat dalam ANOVA tu, dia ada satu general, nama dia general linear model, yang mana dia mengarah kepada fit general linear model, dan ianya lebih accurate kalau nak bandingkan dengan Taguchi method. Sebab Taguchi method pun kalau kita klik dia akan run juga sebenarnya, berapa rank semua tu kan, akan ada orang kata regression juga. Tapi kalau untuk yang ada continuous variable dengan kategori variable yang independent tu, seeloknya menggunakan ANOVA. Dan untuk Kamaru juga, tadi ada sebut pasal apa tadi? Contribution, percentage contribution untuk setiap orang kata control factor tu kan?
Betul? Betul?
Signifikan, tak signifikan kan?
Ya.
Jadi lepas tu nanti dekat situ nanti adalah 80% contribution, 70% contribution. Tapi
Yes.
antara semua control parameter itu, yang mana yang lebih signifikan?
Okay, based on my research, the most significant is the wall angle. Mean the effect of the wall angle, the wall angle parameters will affect the spring back on teleweather blank.
Okay, macam mana nak tentukan? How do you determine how significant that control factor?
The significant is the value of significant is automatically calculated by the Minitip software. So we just put the value of the each parameter, then the response. Means my response is spring back. So I have a both spring back on both different type of materials. So based on the data, the Minitip will process, then give their own based on their calculation, they will give their prediction based on the ranking. Means the Minitip itself will decide this is the most contribution factor of a spring back based on the value response that we substitute the value into the column in the Minitip. Okay. So means the ranking of the ranking of the each parameters will show the percentage contribution of the parameter itself.
Okay. Untuk contribution betul, tapi tadi ada sebut dekat conclusion pasal significant. Bila significant, dia tak sama dengan contribution, betul? Kita ada, let's say ada 3 control factor ataupun parameter yang kita kaji lah, independent variable tadi kan? Let's say 3 lah, saya tak sempat tadi.
Okay.
Let's say ada 3 control factor ataupun parameter yang kita kaji, dan responnya sekian. Contohnya macam angle of spring back.
Yeah.
So dalam ketiga-tiga parameter itu, kita akan plot guna ANOVA. ANOVA akan bagi percentage contribution, let's say 90%, 80%, 60%.
Yeah.
Tapi dalam ketiga-tiga ini, mana yang lebih signifikan? Sebab kalau logiknya, okay, of course lah yang 90% contribution tu, yang tu dah paling signifikan.
Okay.
Betul. Tapi kalau dalam statistik, signifikan ni, dia tak measure dari segi percentage contribution tu. Sebenarnya, kita kena buat satu lagi test, ada kat dalam Minitip, nama dia null hypothesis. Yang tu yang kita tengok p-value tu. Kalau atas 0.05, bawah ke 0.5, kita boleh reject that let's say ada 3 parameter, kita boleh reject satu. Maksudnya tak signifikan. Tapi contoh tadi 90, 80, 70% contribution. Dalam banyak-banyak ni sebenarnya boleh jadi ketiga-tiga ni semua signifikan. Semua signifikan sebenarnya. Tapi tengok p-value dia. Kalau p-value maksudnya kalau nak sebut pasal signifikan, nanti kalau nak bincang dalam tesis ke apa pasal signifikan, kena buat null hypothesis. Kena tengoklah nak reject null hypothesis, nak accept ke tak yang p-value tu. Sebenarnya ada je kat dalam Minitip tu.
Betul.
Itu je. Maksudnya nak sebut pasal contribution dengan signifikan sebenarnya yang berbeza lah, 2 benda yang berbeza. Ya. Itu je kot daripada saya.
Okay, baik. Terima kasih.
Okay. Kongsian.
Okay, terima kasih banyak Syafiee. InsyaAllah nak viva soon kot. Many good point raised by Syafiee actually. Probably please take note lah. In your study, for those who apply Taguchi and also at ANOVA or other regression or statistical methods. Okay, I have also a question for Kamarul and Amir. Okay, the question for Kamarul, why you choose 6061 and combine with the 5052? Is there any potential application of this type of blank out there?
Okay, thanks. Thank you for the question, Doctor. To be honest, there is some combination of alloy in actual parts out there in industrial, but since they have a so combination alloy and I also refer for a previous work on FHST welding, so the 6 series and 5 series is a better combination. A series, 6 series of aluminium and 5 series of aluminium is a better combination because the previous we also already test the combination of alloy but different grade, which is 6 series and 1 series of alloy, but they produce so many times, but the result is very low joint lah. They cannot combine between 1 series and 6 series. So if the question asking for the implementation of the combination 6061 and 5052 on industry, there is I'm not sure on that. Means the application directly on that type of grade of material in the real industrial part. But the previous research on combination of the 6061 and then 5052 is quite common. That's it.
Yeah, it's because it's important because usually you will need to answer the significance of your research. If your research outcome is no clear application of it, so why you do research if there is no application for that particular blank? That's the thing. But you need to think and need to find whether what are probably there is application about for that particular blank, but I'm not really sure. You need to find. Okay, Azam, thank you very much for the attendance. Okay, for Ami, I think since you are you will further test on the crashworthiness. Most likely tensile strength is the main thing or main parameter or main KPI to be achieved. From your result, does your tensile strength, the highest tensile strength obtained from the joint, which what type of joint is not an issue, suitable to be applied in any structural application?
Okay, for me, first, I compared the tensile strength between the different thickness of material, different thickness with same material. So the result is by doing the double butt lap joint, the tensile result is same. What we can we call it? It seems as the result same as the result for the butt joint, but different thickness. So, for example, before this, I tried with the FYP student to do it tensile strength for between 2 mm and 2 mm thickness versus my thickness 1 mm, 1.5 mm and 2 mm, and the result is similar. But I think I have the advantages because I am using the different thickness, but with most I think the what we call the combination of the material is more slight. is more slight as compared to the 2mm and 2mm. So I think by comparing the tensile strength, I think the joint, the double butt leg joint, can be applied to the structure for the crashworthiness study. For me, I think.
All right, okay,
Boleh
thank
tambah tak?
you. If there is any question from the
Oh,
audience?
Saya nak tanya satu benda lagi untuk Amir kan, sebab pasal tadi buat pasal crash. So since buat pasal crash, apa nama tu, tensile test yang buat tu cuma guna satu strain rate je kan? 2 mn per minute kan?
Memang sekarang ni saya guna satu rate lah.
Satu rate je. Sebab kalau biasanya kalau untuk yang crash kalau crash fiziknya berlakunya dia different kelajuan kan. Dia impact mula-mula laju, kemudian sampai satu tahap impact tu dia berhenti. Maksudnya dia material tu dia apa? Melalui different strain rate. Jadi mungkin itulah sebab dia berlakunya strain hardening kat situ kan. Bila different so saya tak tahu sebab dia fokus kepada crash. Mungkin saya tak tahu mungkin different strain rate dia orang ada letak ke different strain rate untuk crash?
Dia sebenarnya kita untuk study crash kita tak study melalui tensile.
Oh, tak study
Sebab dia impact test. Untuk kita nak compare dengan crashworthiness, dia tak boleh melalui tensile. Tensile tu untuk kita nak study dia punya joint. Dia punya joint.
Okay, I see.
So bila kita nak study crashworthiness, kita kena study melalui impact test dan kita kena bentukkan dululah dalam telewedded blank tu kepada structure. Barulah kita boleh study impact test sama dalam bentuk 3-point bend test ataupun slack test dan sebagainya lah.
Ini fully eksperimen lah. Kan ada simulation juga?
Fully eksperimen.
Oh, fully eksperimen.
Setakat ni I'm planning for experiment only.
Okay, mungkin okay, I see. Kalau buat simulation, kita kena ada different result untuk tensile test, different strain rate sebab kita nak tahu dia punya material properties yang tu lah untuk buat crash ke impact ke. Yang itu.
Ya.
Okay, ya. Itu.
Okay, thank you.
Okay.
Inshallah, later probably we will get help from Syafi'i lah to model for that crashworthiness test. Boleh?
InsyaAllah. Abacus.
Alright, okay, already 4:30. Okay, last call for any question. Alright, thank you very much. A very fruitful and good conversation today. I think a lot of questions, a lot of input got from the participant audience, even though probably from my ex-student and student only. But no problem. This is how we grow lah. We still very, very tiny in the research. Hopefully, we get something, or you got something from the webinar today. And hopefully, in next 2 months, there will be another webinar. We are planning for that. I will discuss with the potential presenter after this. Hopefully, we will get a new student. Hopefully, I think we have 4 new students from various countries. So hopefully, they will share their outcome for the next few months. All right, with that, I think that's all for today. Thank you again for the participant who joined us today, and hopefully you will have a nice day. And okay, assalamualaikum warahmatullahi wabarakatuh, and very good afternoon.
Waalaikumsalam. Terima kasih.
Hai, Zul nak tanya apa, Zul?
Salah. Okay, Wassalam.
Thanks,
All right.
Dr. Amol.
Okay. Thank you.